Alright, so for this first one, they're both square roots, so we're going to treat it like this. So when I prime factorize that, I'm going to take all the factors and put it under one radical. So we have all those. So those are all going to go under this radical. So I have a pair of 3s, a pair of 7s, and a 2. And then x to the 7th and x to the 4th is x to the 11th. Alright, so now I'm looking for pairs. There's one, and then this has 5 pairs. So there's an x to the 5th on the outside with 1 left over. The 2 is left, so that stays in there. And then we get a 3 on the outside and a 7 on the outside. So it's 21 x to the 5th square root of 2x. For the next one, I would simplify anything if possible within here before dealing with the radicals, but I can't because nothing goes into 7 and 125. So I'm first going to simplify the bottom, top and bottom as much as I can. So this is going to give me root. This has 4 pairs plus 1 left over, so it's x to the 4th. And then that 7 remains under, there's an x under. This is 5 times 5 times 5. So there's a pair. So that's a 5 on the outside. And it leaves me with a root 5y on the inside. Now to rationalize the denominator, since this is really like an index of a 2, I need pairs of numbers. So what I'm going to do is multiply by root 5y. Come on now. Come on. Root 5y. Alright, so that this times this here is going to give me just a 5y. And then I still have that 5 there. And then the top is going to be the x to the 4th square root of 7 times 5 is 35xy. And then I'm going to simplify the 5 times 5 as a 25. There you go. Easy as that. Let's do another one. We got another minute. Alright, so this tells me that I'm looking for groups of 4. And so I'm going to factorize the 405. That is, what was that, 45 times 9. And then this is going to be 9 times 5. So I already got a pair of 9s. So I should be clever enough to take out my pair of 9s. If not, continue factoring and get my 3s. Oh, I don't want pairs. I'm just kidding. That was funny. I'm looking for 4s. So I've got a quadruple of 3s, 4 3s as factors. So I'm going to take a 3 out. X to the 6th. Well, 4 of the x's give me a group of 4, so it's an x to the 1 on the outside with x squared left over. Let's write that. Thank you. Y to the 7th. So that gives me a y on the outside. It leaves me with y cubed underneath. And the z to the 8th. Well, 8 z's multiplied, which is what z to the 8th means, is like 4 groups, or 2 groups of 4. So it's a z squared. So there's our final answer.